Hello students, welcome to our page Samyak Academy for Physics. I hope you already subscribed our page. If you haven't done that, I am going to request you that please like, subscribe and share our page, and also press the bell icon so you will get updates in the future. Now today we are going to start the next concept from the chapter number 6, Refraction of Light, obviously, which is from the chapter number 6, which is from the Science Part 1. And for the class 10 we are considering these lecture series. So in previous 3 lectures we had considered concept of refraction of light, how refraction of light is going to occur, then some concepts regarding refraction of light like Snell's law, twinkling of star. All these factors we had considered in previous 3 lectures, and if you haven't watched those videos, I had shared the link in the description so you can watch those videos also. Now here today we are going to start the next concept, which is very important concept in our day-to-day life which we are observing, which is dispersion of light. So here we have to consider first of all dispersion of light, when it is going to occur, what are the conditions, like we had considered conditions for twinkling of stars or conditions for refraction of light, from where it is transferring, rarer medium to denser medium or denser to rarer. Like these all conditions we had considered. In the similar way we are going to consider about the dispersion of light. Now it is very interesting concept. Now here the dispersion, if we consider word by word meaning, so here dispersion, if I consider the first word which is dispersion, so here if I will use the alternate word for this dispersion, then that is going to be separation. So what is the alternative word for the dispersion? Here separation. And again we have to consider the separation of light. What we have to consider? We have to consider separation. Whose separation? Separation of light. Now according to which concept we are going to consider this separation? For which factor we are going to consider this separation? So the process of separation, of light, which light? White light. Here we have to consider the white light. So the process of separation of white light into its component colors while passing through a medium is called the dispersion of light. So here light should pass through a particular medium. So whether it is denser medium or rarer medium, it doesn't matter. So it should be transparent medium. That light should be traveling through the transparent medium, and it should be more dense as compared to the first medium. Suppose if you are considering both the air mediums, no problem, but second air medium is filled with some amount of water, then also we are going to get the dispersion of light. Or directly the second medium is glass medium, first medium is air medium, then we are going to get the separation of that white light into its component colors. That means every white light had some component colors. That means it is made up of 7 types of colors if we consider the number of colors. So every white light is made up of 7 colors. So those 7 component colors are referred as a spectrum of that white light. And which colors are involved? So if you consider the sequence, then it is going to be V, I, B, G, Y, O, R. This is the sequence. So here V for violet. So first color of this sequence is violet. Then second color of this sequence is indigo. Violet, indigo, blue, B for blue. Then G for green, Y for yellow. Okay, then O for orange, and last one R for red. So it is going to consist of 7 colors: V, I, B, G, Y, O, R. Violet, indigo, blue, green, yellow, orange and red. So these are the 7 colors of white light. These are the component colors. And the light, if we consider how that light is going to obtained in its component colors, so for that purpose we have to use the prism, actually glass prism. So glass prism have three refracting surfaces. Glass prism have three refracting surfaces which are rectangular in nature, and it has two triangular surfaces. So those triangular surfaces are considered as their bases, and here actually that white light is passing through refracting edge, one of the refracting edge, so due to which it is showing the refraction inside the prism, and then inside the prism it is splitted, that means it is separated into its 7 constituent colors, and after second refraction from the second edge of the prism we are getting the dispersion of light. And you can see here the sequence is shown V, I, B, G, Y, O, R. And if we consider the deviation means the light is bended by how much angle as compared to the original path, so that is the deviation. So if we consider the deviation, then for the violet color this deviation is maximum, and for the red color that deviation is very low. That means if you measure the angle of deviation, so here this red line I am indicating with original path, so whatever be the angle is formed by that red beam with that original path, so that is going to be angle of deviation, and it is going to be denoted by delta. So here you can say that delta V is greater for that spectrum, and delta R is the lowest, and remaining colors are lies between that value. Suppose violet color having the angle 40 degree and red color having the angle 20 degree, then remaining colors will have angle of deviation between 40 degree to 20 degree. They will not go beyond those limit, red and violet. So this is the dispersion of light which we are getting when light is passing through the prism. So here out of these colors, now it is about the deviation. Just I had told you that violet color has maximum deviation and red color has minimum deviation. So exactly reverse to that you have to consider wavelength. So red color having the minimum angle of deviation, but it has maximum wavelength among all the colors. So which color going to have the maximum wavelength? The red light has maximum wavelength, that is it is close to the 700 nanometer or 7000 Armstrong unit. 700 nanometer, or it is also has another unit which is Armstrong unit. So capital A, and on the head of that capital A you have to put down very small 0, so that is a Armstrong unit. And here 1 Armstrong unit is equals to 10 raised to the power minus 10 meter. So just remember this conversion. So these conversions are also very necessary in the higher levels, so you will require this conversion. So just remember which color has a maximum wavelength. Red color has a maximum wavelength, and opposite to that violet color is going to have the smallest wavelength, which is close to the 400 nanometer or 4000 Armstrong unit. And here you have to remember the conversion. 1 nanometer is equals to 10 raised to the power minus 9 meter, and 1 Armstrong is equals to 10 raised to the power minus 10 meter. So these are some conversions in case of wavelength we are using. So generally wavelengths are either in the Armstrong unit or either in the nanometers. So you have to remember both these conversions. So here you can see the actual prism. Now you can see the glass prism. You can see 3 refracting edges are there. Okay, so they are rectangular in nature. Okay, the first surface is from which light is entering into the prism, then second refracting edge is from which that light is coming out, so that is going to be referred as emergence. Second refraction is referred as emergence, and then we are getting the dispersion also. You can see the sequence here. See at the downside you can able to see the violet light. Okay, it is present at the downside, that means the angle of deviation is maximum for it, and at upside you are able to see the red light, and remaining colors are lies between that: violet, indigo, then blue, green, yellow, orange, red. So sometimes some colors are appears very thin, that means their ray or their beam is very thin, and some colors having the larger beam. So it depends on material of prism or which white light we are using. We are using sunlight or we are using mercury light or like that. So you can not mercury, sodium light we are using because it is a white light. So it again depends on medium. Again angle of deviation is also depends on medium, but remember violet color has the maximum deviation and that of red color having the lowest deviation. And in case of wavelength, the red color has maximum wavelength and violet color has the smallest wavelength. So this is the concept of dispersion of light. So just remember, dispersion means separation of white light into its component or constituent colors is referred as a dispersion of light. And whatever be the colors, those 7 colors which we are obtaining from that white light, so the sequence of those 7 colors, which is V, I, B, G, Y, O, R, that is referred as a spectrum of white light. And that spectrum lies between 400 nanometer to 700 nanometer. And conversion also you have to remember, 1 nanometer is equals to 10 raised to the power minus 9 meter. 1 Armstrong unit is equals to 10 raised to the power minus 10 meter. So these are some converges which we are using in case of wavelength. So I hope you understand this concept, dispersion of light. So I thanks you for the watching this video. So thanks for watching this video, and again I am asking you, if you are new to our page, please like, subscribe and share our page, and also press the bell icon so you will get updates in the future. And stay tuned with us for next upcoming video of this lesson and then remaining lessons. So again, thanks for watching the video. Have a nice day.